Hello world. Here I want to give you a good solve for this absolute peach of a section B question of the AQA computer science. This is the one that would have gone live in 2020. It's a shame it didn't happen because I'd be curious what the examiner's remarks and notes would have been, because it's as far as section B problems go, this is one at the sort of spiciest end of the scale. It's about modes and modal frequency. So we want to write a program that asks the user how many numeric digits they would like to enter, and then gets the user to enter that number of numeric digits being between 0 and 9. The program should calculate and display the number of times the most frequently entered numeric digit was input, not the digit itself, but like how many times. There's an example. If I have 4 digits, 3, 4, 5, and 3, is going to display the value 2, not the digit 3, because 3 was input 2 times. And then if there's more than one, we want data with multimodal. And there's some tests. There's a multimodal case, and there's a single mode case. So this one should return multimodal. This one should return 2. Okay, so here we go. This is an exercise in decomposition. So we want to read n, the number of digits. Then we want to read n digits. Then we want to count the digits read. And then we want to display the largest count slash multimodal. That's the first decomposition. Some of them that would be one line, but this is what we're so in between we want to presumably figure out the largest. I encourage you to decompose in English as much as you can, because this is going to be one line of Python. This is going to be a couple of lines of Python, but then read and count. We don't really need to store the digits. We just need to store the counts. So counting as we go along. So what we're going to storing, essentially we want to store slash build a list of counts. I'm going to call them frequencies, because that's the sort of statistical language for this, right? The mode is the largest frequency. Frequency is how often a given entry or something occurs. So now we're kind of like starting to look like something we can Pythonize. So it feels we're going to read n. We're going to initialize a frequency list. So here I'm just going to want something that starts as like 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 60 measures here. So that's 1, 2, 3, 4, 5, 6, 9, 10. Which means that if I say, okay, so if I say frex equals this, we're also going to say n is equal to int, the classic int input, that people know from year 9, and it's like number of digits, question mark, space. We get this frequency list, and that means that if I do frec 0, that's this number, and this could be my counter for the number of zeros. So essentially I've got 10 variables, and I've got a neat way to access exactly which variable I want to change as it goes along. So get my frequency list, read n digits counting as we go along. So counting as we go along means that we well, let's read n digits counting as we go along. That means increment the relevant index, or sort of like item in frec. So for I in range n, big N, comma. Let's move that. Sorry, I need to make that like massive because it's a screen share, isn't it? Yeah, that's better. So for each of these, we're going to say d for digits, for digit singular, is equal as the int input of digit. We can even say like, if you want to be fancy, I've seen one of my students do this. I was very proud. The rest exercises wasn't so great, but like since you've got the counter I, might as well. So we can say digits number with the hash, and then I colon and the space, so that I'm going to start as a user is going to start everywhere next to it. I've got D. So then I'm simply doing frec at index D becomes equal to frec. So it's frex plural. Frex at index D plus 1. Now I've got the count. So that's what I'm doing with, I've been kind of storing, building a list of counts. Up. Now figuring out the largest. Well, let's see if this works, right? So like we'll also encourage my students to do is to test their code as they go along. So I've done a bit of something because it's already two parts, reading and then figuring out the count. So I'm just going to print frex just to see if this works. So Control S, Control F5. I need to put myself in, just like the run button is at the top left. Go. Start to worry about time. No, we're 5 minutes in. We can probably do this. Number of digits 3, and if it's I'm going to say 0, no, it's 1, 1 again, and then 4. And I've got 2 at 1. That's 3, 4. There's event 0, 3, 0, 4, and 1, 4. So I have correctly built the list in which I just want to figure out the maximum of that list. Right. So figure out the largest. Let me comment my Control/comment my test debug out. To figure out the largest, you could just say like sorted. Okay, like, there's the question about can you use Python constructs. Remember the AQA A level is like supports 4 languages. Don't flex and be too Pythonic. But if you were to do sorted frex bracket zeros, like the top one at sorted, I'm assuming this is going to sort it. We might need 9, right? So it depends if it's kind of like incrementally or decrementally, and we take the large one. So this is kind of finding a maximum. So I'm going to say mode is equal to, at the moment, that's 0, because that's going to be incrementing, and for f for frequency in frex. So here I'm not using a number that increments. This is going to take values that are stored here. So with my example, if I still have the terminal, in my example, this is going to take value 0, 2, 0, 0, 1, 0, 0, etc. Right? It's not the number like here in range. This is the I will kind of tick along. This is literally picking up the elements of the list. It's important to make that difference. So for f in frex, if f at index, no, not index, sorry, if f, because that's the frequency, if that's larger than the mode, the current mode, then the mode becomes equal to f. And then I'm just going to put an elif. The f is equal to the mode. We're gonna can I get along with this? No, I can't get away with this because there's going to be zeros to start with, I think. So this is what I'm going to need to say multimodal or simply mm. That's a boolean. And I'm going to assume we have a single mode, false, can't type under pressure. So the mode is f, and if it's equal, mm is true. Now what you want to do here is be very, very careful, because there may be spots on the way. So if I've got say, within those zeros, right, like this is going to look multimodal until we realize there's a mode. If there were 2 zeros before that, or if let's say we get 2, 4, and then like later on we discover there's an 8. So we want to make sure that every time we find a new valid mode, we flick back the flag back to false to say, well, like we found a current new single mode, then we assume that we say it's not multimodal, and in the moment we find a second mode that's equal, we say it's multimodal. So that by the end of this, we simply do if mm. So by the end of this, the flag has the correct value, whether it's multimodal or not. We print. This is where you want to be like very careful and say, I'm not going to data was multimodal, right? You're probably not going to be able to do this on the exam because they don't give you a kind of digital whatever copy of the question paper, but they oh, I think my Shift D is bound to something. I can't type a capital D. All right, whatever. Data was multimodal. Yeah, I'm doing this. I've not rehearsed this. As you can you tell? Else we're going to print f string. We know and love them, or simply. Now let's keep it simple. And what do they want? Let's not stress about the time. I'm stressing about the time. There's 5 minutes left. But what we want is. Oh, they don't tell you about the message, right? Yeah. So like, I mean, kind of. Technically, it's modal frequency or mode frequency. which is not the mode itself, but how often it appeared. Modal frequency, colon, and then just a comma and mode. This ensures a print. You put two arguments and separate them out of space. Save this. Let's have a look. Can I control minus my way out of this? Not too bad. I could sort of tidy this up. Yeah, whatever. Okay, let's run this. Let's try it with this so we can see. If I left very confident, we first are going to test 6 digits, which are 0, 1, 2, 1, 2, and 1. The modal frequency is 3. That is correct. There's 3 ones. And then run it again. Now this time we get 5 digits, and it's 0, 1, 2, 2, and 1. And the data was multimodal. And in that time, right, it's like with 4 minutes to spare, we've solved the spicy section B. So there's a bunch of gotchas here, right? Like you need to figure out what you're doing, right, and how you're doing it. I've seen it's natural to want to just read all the numbers, put that into a list, and then go over that list and figure out either every single frequency or all of the or just the mode or the maximum. What happens here actually is that because we're going to be building frequencies and there's updates in frequency D, we can actually do that mode calculation inside that loop. That is very elegant. I was very impressed when I saw a student do that. Okay, we get time. Let's have a look at this. So let's see if I can get this right. So we need to assume same deal, right? We're kind of going to move those initializer out of here. Why is my control X? Thank you. Right, and then this is my basic increment. And at this stage, if frex at index D is larger than the mode, well, actually, let's just disconnect. Let's just paste this in as well. I mean, copy that. Multimodal is false. And the mode is equal to, in that instance, not F anymore, right? It's frex D that we've just updated. And then we need an elif f frex at index D. This should be indented in. If that's equal to the mode, then at this point in time, the data is multimodal, and we don't change the mode. We just that's what's happened. The reason this works, right, is that when we do it here, we are going over the whole list of frequencies. But if we do it as we go along, we will go over the last time any digit was entered, right? The last one I entered, then at this point in time, frex at 1 is the correct frequency value, like the final one, which means that we still go over all of the frequencies, or we're kind of not in order, and sometimes we might go over the same one several times as it increments, but it has the same effect of going through the data structures, so that by the end, the value of our flag and the value of our mode is indeed correct. So we can remove that because we're not doing this anymore. That's like this should actually go here and save it and run it. Just kind of do it again. The first one was 6 with it like 0, 1, 2, 1, 2, 1. Modal frequency 3. Run it again. 5 digits. 0, 1, 2, 2, and 1. And the data was multimodal. So we have condensed this into, yeah, and that's like with the comments, right? So that's 20 lines if you kind of condense it. It is the spicy one, right? Like remember the value of this is not like in how you do it and what I've done. It's just sort of decomposing the problem and working for it logically. I hope this helps you in your endeavors, be there the actual AQA GCSE or any other coding exercise, be the academic or otherwise of that type.